Low temperature resistant nylon mainly depends on the type of modification, such as super tough or fiber toughened, or similar to the type of thermally conductive nylon. The understanding of the low temperature resistance is different for different species. For example, the so-called ability to withstand low temperatures. I think there are generally three cases. The first case is, no changes are made to the product, put into cryogenic freezing, freezing for a fixed hour, or high and low temperature cycles for a fixed hour. That is completely plastic products, does not have any metal parts inside the case. Then we judged at this time the material through the high and low temperature cycle. Back to room temperature, whether it can still maintain its own mechanical properties or integrity. That is to say, this product after the high and low temperature, back to room temperature, its performance will not be destroyed. This is a situation that this situation is often not particularly demanding. No force is applied. No filling package. This is one of them. The second is that there is a grouting package. The so-called grouting package. You can understand that there is actually force. For example, thermally conductive nylon has an aluminum cup in the middle, or some structural parts of nylon that needs to fill the middle of the metal parts, or handle inserted in the middle of these. At this time, do the low to high temperature or room temperature to low temperature. Now the two processes. It is clear that the expansion coefficient of this thermal expansion and the contraction of metal compared to nylon is certainly not the same. Usually I think the plastic factor is definitely greater than the metal, that in the process of low temperature, the plastic may shrink faster than the metal, and the metal to hold it apart. So this time you cannot say that it did not force, it is force-bearing. But this force has no way to change it. Why? Because of thermal expansion and contraction, the force generated by this I understand is very large. If you want to stop the shrinkage or the expansion by the good properties of the material, I think it is impossible to take the expansion of the metal and restrain it. That time is the need to reflect this nylon modification to have a better elongation. Just like Mr. Zen said, you need to pay attention to the elongation, which also allows it to deform. What about deformation and not causing damage? This is the second case. That the third case, that is, this material in the case of -40 degrees or lower temperature to achieve cold resistance. At the same time also in the ultra-low temperature to do drop ball impact or do some destructive experiments. Then this time is really think that. Say low temperature depends on how much impact. This is often reflected in a low temperature impact resistance. Can be notched impact, can also be notched impact. That of course also pay attention to the elongation. So roughly I think low temperature resistance is probably the three main categories just mentioned.